And I'm going to kind of talk about it, and I'll also reference your quiz. I would say most of you were good on the substitution, the graphing, and the elimination. Would you agree? Yes, most of you. People make silly mistakes, okay? So I just remembered that special cases, because I don't think you got one in this class. A special case, remember if it's special case when it's graphing, if the lines are parallel, then there's no solution. If they're the same, then it's all real numbers. So this would be no solution, and this would be all real numbers. And then also, if you're doing substitution or elimination, and the special case happens where the variables cancel out, if it's a false statement, then it's no solution. And if it's a true statement, then it's all real numbers. So again, that wasn't on you didn't get one of those on your quiz, okay? We did review it then, but I want to make sure we go back over that. So you're going to see, I think there's 4 systems in which you kind of get to choose elimination or substitution. You might get a non-linear one where it's squared, and then you're going to get one in which you're going to be forced to graph. So just make sure you'd be able to do that. Okay. So we're good on that, yeah? Yeah. And the same goes for the beginning of 7-2, which was elimination. So these are just some sample problems, but I think you guys are okay, right? Yeah. So some of the word problems. I would just say 1, make sure you have your calculator with you because it's going to make your life easier. Scientific calculator. You were right the first time. Scientific. We can't use a graphing calculator? Come on. I showed you how to solve a system on that thing. It's a graphing calculator, and there's graphs on your test. You have to ask Ms. Quest that again. Yeah. You can use a scientific one. Okay. I would say most of you did okay on something like this where it was the stocks question. I did different ones. Did you guys get a stock one? No. So, but depending on your quiz version, you got different types of questions. Be prepared to do any of them. Okay, we've gone through ones with stocks. We've gone through ones with systems with like my other class I gave like the cheeseburger or calorie, that kind of thing. Ticket sales, perimeter. So you guys got the ticket sales, right? Okay. Be prepared for all that stuff. All of those problems, there was review ones on the quiz. There's also review ones on the test review and the extra test review. So there's lots of ways for you to practice those, but obviously be prepared for any of that kind of stuff. One of the ones that you did get that's a little different on your test is like a break-even one. So on your quiz, I gave you the cost function and the revenue function. You will have to come up with your own cost function and revenue function for your test. So if it said something like this, Miss Braun is invested $14,000 in equipment to print yearbooks for Archbishop McCarthy High School. Each yearbook costs $7 to print and sells for $35. How many yearbooks must she sell to break even? So you have to come up with, it'll say the cost function and the revenue function. And what that means is an equation to represent cost and an equation to represent revenue. Okay. So what part of this information is cost? $14,000. The $14,000 initial setup fee and $7 per item, right? So I would write that as C equals 7x plus 14,000 or 14,000 plus 7x. That doesn't matter the order. So any kind of initial setup fee you would need to include plus whatever it costs to produce each unit. And then your revenue is what? $35 a unit, so it'd be 35x. So part of your question is just going to ask you to come up with your own cost, your own revenue function, and then find your break even. So to find the break even, I set these equal to each other. So I'd get 7x plus 14,000 equals 35x. Subtract the 7x. And divide. And you get, what, 500, right? Yeah. So that is her break-even point. If it's a nice whole round number, which is what happened to you on your quiz, this will not happen to you on your test because we've talked about this a couple of times. If this said 500.1 and you're trying to figure out how many things you need to sell in order to break even, what's unique about the rounding here? You have to round up. If I round down, she doesn't make enough money to break even. Does that make sense? Yeah. So you have to round up on these. So if it was 500.1, my answer would be 501 units. Questions on that? Okay. Then you had equilibrium point, and so some of you lost credit on this because you didn't answer the entire question. It says, find the equilibrium point of the demand and supply equations, the price, P, and the number of units X that satisfy supply and demand equations. So this should be a relatively easy question, especially with a calculator. They both equal P, which means I can set them both equal to each other. This would equal 0.5x minus 45, and this is obviously going to be easier to do with a calculator than without. So this is 200. So that is the number of units you need to sell, which is half of your answer. The other half is at what price should you sell those units. So how would I find that? Just take and plug it back in. It doesn't matter which one you plug it back into. If I use this one, I'd get 0.5 times 200 minus 45, or 100 minus 45, which is 55. So again, some of you lost credit on that question just by not providing both answers. Make sure you read it carefully. Yep. You can, so actually I'm so glad you said that. You can multiply your demand by 100 to get rid of the decimal on that side. So think about what's happening if you do that. If I multiply the demand by 100, if I set it up as though it's a system, right? And I multiply it by 100, that P is now 100. And if I only do 10 here, now I can't set them equal to each other. Does that make sense? So if I'm intending to set them equal to each other, whatever you do to one side, you have to do the other. So if I multiply that first one by 100, I have to multiply the second one by 100. Does that make sense? Or you can just wait till they're in a line together and you'll be able to see that. So once I set them equal to each other, like if I'm looking at it from this line here, hopefully you catch that they'd have to get multiplied by 100, because on the left is 100, but on the right's 10. But I would say that that's when, and that's if you don't have a calculator. If you have a calculator, let the calculator do the work for you. All right, question. So that's a lot of, again, there's still going to be ones, like you did one on perimeter. You'll get ones on ticket sales. You'll get ones on, all different kinds, okay? There's lots of different types of systems that you could get. You might see a distance system. I didn't put the headwind, tailwind on there, but you could still see a distance, like a round trip. If somebody's going someplace and back, then distance would equal rate times time, something like that. All of those would be systems equations. System word problems. All right, then 7-3. So the 7-3 on your quiz had 3 problems. Numbers, let me see real fast. Number 7, 8, and 9 were all from 7-3 on your quiz. So 7 and 8, you won't get questions just like that. 7 you will see when we have to do the back substitution part of the Gaussian elimination. And then 8, you're going to do a solving system like that with a Gaussian elimination or a Gauss-Jordan now. So if you wanted to redo number 8, now that you know the answer, if you wanted to redo number 8 using one of your matrix methods, it would probably be good extra practice. What you will see is a question like 9, which is your partial fractions. And what's not on that quiz, because we covered it the day after, was the partial fraction with a repeated factor. So that's what this example is, right? So you're going to get one regular partial fraction and one with a repeated factor. So in my denominator, my x is repeated. It's x times x, which means when I went to write this out as separate fractions, I would have to write a over x plus b over x squared plus c over x minus 1. So that factor repeats. I have to work my way up to it. So then when I went to do the next step, I would multiply a by what's missing in its denominator, which is the second x and the x minus 1. B would get just x minus 1. And c would get x squared. And then I would rewrite out my numerators. So 4x squared minus 2x plus 1 equals a x times x minus 1 plus b x minus 1 plus c x squared. And then I would distribute out ax squared minus ax plus bx minus b plus cx squared. And then we had to group together our like terms. So everything with an x squared got grouped together. So 4x squared would equal ax squared plus cx squared. Negative 2x would equal ax plus bx. Or negative ax, sorry, that's a negative. And the constant, which is 1, would equal negative b. So then from the first one, they all had the x squared, so I divided by x squared to cancel it out, and I got 4 equals a plus c. From the second one, they all have an x, so I divided by x, and I get negative 2 equals negative a plus b. And then on the last one, I already know b would be negative 1. So I've already solved for the first one, and then I want to take and plug them back in. B could come here. Negative 2 equals negative a minus 1. Add the 1, negative 1 would equal negative a, and a would equal 1. And then take that and plug it in here. And c is 3. And then I plug that back into my initial fractions. So the a, which is 1, goes over the x. The b, which is a negative 1, so this is minus 1 over x squared. And the c, which is a positive 3, over x minus 1. Now these were nice whole numbers, okay? It totally happened by luck. I just literally randomly threw those numbers out last class period. They will not be that pretty on your test. They're not that pretty on your review. So make sure you practice with the fraction. Remember, if the fraction's on the top, you have to pull the denominator down to the bottom. Some of you made that mistake on your quiz. And now for your test, if there's a like denominator, you need to make sure that you pull it out front. So if all of them had a 3 on the bottom, I would pull out a 1/3 on the front. If all 3 have something you can pull out, even if it doesn't take it completely out. So let's say there's a 3, 3, and a 6. You could still pull out the 1/3. I'm not going to make you change them so they're all 6, but you can pull out the 1/3 to at least reduce it. If 2 of them had 3 and then one of them didn't, then you can leave it because you can't take it out of all 3. So again, I added a repeated factor onto your review. Make sure that you review it. So there you would take out the 1/3. Yep. And then I literally changed today the way the questions are on 7-4. I was just really concerned about time. So instead of initially I had to do one whole problem of Gaussian elimination with back substitution and then a whole new system for Gauss-Jordan. Instead, you are going to complete it twice. Same problem. The first time, Gaussian elimination with the back substitution. So this is your row of 1, 0 below, and then the triangle system, you work your way up. And then you're going to flip that page over and rewrite your last remaining matrix from the front, which is your row echelon. And then you're going to use Gauss-Jordan, which means put it into reduced row echelon. So you're actually checking your answer from the first question by doing the last question. I'm hoping it saves on time. I'm hoping it catches some mistakes, okay? But that's what you should expect. So I would say the same thing if you wanted to practice it out. Start with this one, get it into row echelon, do the back substitution, and then continue it on to Gauss-Jordan or reduced row echelon to check your answers. All right, so the first thing I'm going to do here is rewrite this into matrix form. So -6, 5, 2, -11, -2, 1, 4, -9, 4, -5, 5, -4. And the first thing I usually want to do is get a 1 in the top left corner location. This time it's not as easy to get the 1. There's nothing I can switch around. If I start to multiply by a reciprocal, it will give me fractions somewhere else. So if you can sort of look at what would be the least pain in the butt fraction to do, and I would say even if I just stick with that top row and multiply by the -1/6, I end up with a 1, -5/6, -2/6, which is -1/3, and +11/6. So sometimes you get fractions and you can't avoid them. And here's my new matrix. And then from here, I would usually work to get a 0 in this spot. which means I could either multiply that top row by 2, or because there's fractions there, another thing I can do is multiply row 2 by 2 and then add it to row 3. So I'm going to do that. 2 times row 2 plus row 3. And I would encourage you to write out each step so you avoid mistakes. So this is 0, -3, 13, -22. And that's going to replace row 1. Sorry, row 2. 1. So now I need a 0 where that 4 is, and I have no other choice but to use row 1. So I'm going to do -4 times row 1 plus row 3. So this would be times 4, positive 10/3, positive 4/3. And a -44/6, which is 22/3. Plus row 3. This becomes -15/3, so this is -5/3. This becomes 15/3, 19/3, and this becomes 12/3, which is -12/3, sorry, which is -34/3. And then I can actually multiply this whole thing by 1/3 to get rid of those denominators, and it'll save me the next step. Because once the 0 is there, I can actually multiply that by 1/3. So now that takes the place of row 3. So row 1 is 1 -5/6, -1/3, 11/6, 0 -3, 13, -22, and 0 -5, 19, -34. So then the next thing I want is a 0 in this location. I can't just multiply one row and add it, which means I'd have to multiply the top row, let's say by -3, or second row. So -5 times row 2 plus 3 times the bottom row, 3, row 3. So -5 times here is 0, 15, -65, positive 110, and 3 here, 0, -15, 57, and -102. So I get 0, 0, -8, positive 8. That's my new bottom row. 1, -5/6, -1/3, 11/6, 0, -3, 13, -22, 0, 0, -8, 8. So then I want 1s in these two spaces, which means I can multiply this by -1/3 and this by -1/8. So I get 1, -5/6, -1/3, 11/6, 0, 1, -13/3, and 22/3, and then 0, 0, 1, -1. So I've got it in row echelon form, which means I can use my system with back substitution. Oh, that's a negative. There's no x, so y minus 13/3, z equals 22/3, and I already know z is -1. So I have my first variable. I'm going to take that and plug it in here. subtract that 13/3, and y would equal 9/3, which is 3. There's my second variable. Take those both and plug them into the beginning. And then I can actually change them all so they multiply by 6. This would be 6x. That would be 3 times 5, 15, plus 3 times into 6 is 2, equals 11. 6x minus 13 equals 11. 6x equals 24. And x equals 4. And there's my completed system. 4, 3, -1. So that would be your Gaussian elimination with back substitution. If I wanted to continue this with, which is what you, so that would be one question, and then what you'll have to do is continue this on to get the Gauss-Jordan method, which is reduced row echelon. So I'm going to rewrite my system, or my matrix, sorry, as it is. This is a 3. And I'm going to work to get zeros in my other 3 locations. So sometimes so I'm going to take this denominator, multiply this times a negative or a positive 13/3 so that I can cancel it with row 2. So row 2 plus 13/3 times row 3. So row 2 is 0, 1, negative 13/3 and 22 over 3. And row 3 times that 13/3 is 0, 0, 13/3 and negative 13/3. So from here, I would add these, 0, 1, 0, and then 12 minus 13 is 9/3, which is 0, 1, 0, 3. Now that's going to take the place of row 2. So now I've got 1, negative 5, 6, negative 1/3, 11, 6, 0, 1, 0, 3, and 0, 0, 0, or 0, 0, 1, sorry, -1. So now I've got to work my way up. So if I want a 0 here, I would have to multiply the bottom row times 1/3. So 1/3 row 3 plus row 1. And I get 0, 0, 1/3, negative 1/3, 1, negative 5, 6, negative 1/3, 11, 6. I get 1, negative 5, 6. These cancel. This would be 2, 6, negative 2, 6 plus 11, 6, which is 9, 6. That's going to take the place of row 1. So row 1, 1, negative 5, 6, 0, 9, 6, which is 3 halves. Middle row 0, 1, 0, 3, and 0, 0, 1, -1. My last 0 comes here. So I do 5, 6 times row 2 plus row 1. 0, 5, 6, 0, 5 halves plus 1, negative 5, 6, 0, and 3 halves. So I get 1, 0, 0, 5 halves and 3 halves is 8 halves, which is 4. And that is row 1. So 1, 0, 0, 4, 0, 1, 0, 3, 0, 0, 1, -1. And from here, I would get x equals 4, y equals 3, and z equals -1. As a coordinate, it would be 4, 3, -1, which is how you want to write it. And this matches what we got for the first one, so we know that it's right.